Okay, so now we're moving on to inequalities. With inequalities, we need to remember, what do the signs actually mean? So this sign means that it's greater than, this one means it's less than, this one is greater than or equals to, this one is less than or equals to, all right? And we normally use these signs when we're talking about, when you're representing X in set builder notation. And here where you have an open circle and a closed circle, so this tells you that the number is not included, and here the number is included, and we usually use these when we are representing the inequality on a number line. Then we have the open brackets and the closed brackets. So this one is almost the same by saying that the numbers here are not included, whereas the numbers that are represented within the closed bracket, the numbers are included. And we use these two brackets when we are talking about interval notation. Okay, so now let's say you were given a question where you were asked to solve for X, all right? And the inequality is X squared is less than 9, all right? So the first step, what you would then do is you would bring the 9 over, okay, so that it becomes X squared minus 9 is less than 0, okay? And then you will factorize this. So it's X plus 3, because it's the difference of two squares, times X minus 3 is less than 0. So you are solving for the values of X, where if you substitute those values into this expression here, then you will get that the answers are less than 0. So which values of X will satisfy this inequality? All right. So when we are factorizing, we know that if this was an equal sign, then we would just solve for X. Then the answer would be X is equals to minus 3 or X is equals to 3 if this was an equal sign. But now it's an inequality. So what we do is, yes, you still do follow that step, but we refer to these values as the critical values, all right? So the critical values are where the solution is equals to 0. So we have X plus 3 times X minus 3 is equals to 0. So my critical values are at X is equals to minus 3 or X is equals to 3, okay? Then I use the sign table. All right, I use the sign table. So this is the first method, all right, where you represent your critical values, okay? So my first critical value, I said, is at X plus 3, okay? My second one is at X minus 3. And then when I multiply the two together, what happens? Okay, because ultimately that's what I want to know. Okay, so then I say I put this in order, right? So from smallest to largest. So I put my first critical value where X is equals to minus 3, and the next one where X is equals to 3, okay? So let me just draw a line here. Okay, let me just draw my lines here. Okay, so I just wanted to get my lines correct. So all I did was, okay, so I want to know my critical values are minus 3 and 3. So I put that in ascending order, okay? And then I want to understand now what happens when X lies between these two values, okay? So let's do it step by step, okay? So When x is equals to minus 3, when x is equals to minus 3, and I put it into this here, okay, so the first one, into x plus 3, when x is equals to minus 3, right, x is equals to 0. You with me? Okay. When x here is equals to minus 3 and I put it in here, I get minus 3 minus 3, which gives me minus 6. So this tells me that this value over here is negative. Okay. So now when I have 0 multiplied by a negative sign, what do I get? I still get 0. Okay. Let's do the same for this one as well. When x is equals to 3, and I put it in here, I get 3 plus 3, okay, which is 6. So this value here for me is positive, okay. When x is equals to 3, and I put it in here, I get 3 minus 3, which gives me 0, okay. Then a positive number multiplied by 0 still gives you 0. You with me? Okay. So now, in between these numbers, you can choose any value you want, all right, between minus 3 and 3. So let's say maybe we choose 1. So if x is equals to 1, and I put it in here, so I get 1 plus 3. So that value for me is a positive value. Okay. When x is 1, I put it in here. I get 1 minus 3, which gives me minus 2. So that's a negative number. And a positive number times by a negative number gives you a negative value. Okay. Then on either side of these, now I want to know what happens, all right, when x, okay, is less than minus 3. So I want to know what happens when x is less than minus 3. Okay, so I choose any value that's less than minus 3. So let's choose minus 4. So what happens when you get minus 4? It's minus 4 plus 3. So this value here is a negative value. Okay, when I put minus 4 in here, I get minus 4 minus 3. Okay, so it's still minus 7. It gives me a negative value. And then what happens when I have a negative and a negative? Negative times negative, it becomes a positive value. Okay? And on this side as well, what happens when x is greater than 3? Okay? So when x is greater than 3, what happens to my values? So let's choose the number 4. So I get 4 plus 3, which is 7. So that's still a positive value. 4 minus 3, that's 1. So that's still also a positive value. All right. And a positive value times a positive value, because now we are multiplying the two numbers, it gives me a positive value. Okay, so now that we have the sign table, we need to find the values that satisfy this inequality. So what does this inequality say? It says we are looking for the x values where, okay, when you multiply the two values here, it's a value that's less than 0. And where do you find that the value is less than 0? If you look here at the bottom of your product, you find that it's less than 0 in this block here. So in this block here, it's less than 0 because it's negative. Okay? And because of that, then I can say my value for x, my solution for x is going to be at minus 3, is less than or equals to x and less than 3. So between minus 3 and 3, if I take any values that lie between minus 3 and 3 and I substitute them back into here, I'm going to get a negative value as an answer. Okay, now when it comes to representing your answers, the way that I wrote it here is what we refer to as set builder notation. Okay, so actually the correct way of writing it is like this. Okay, where you say x is an element of the real numbers. So that's how you would write it in set builder notation. If I was to draw it on a number line, then I would say, okay, between minus 3 and 3, okay, my x value, because it's less than, it's not equals to minus 3, and it's also not equals to 3. So that's why I have the open circle. So my number line would look like that. All right. And lastly, if I was to write it in interval notation, then I would say that it lies between minus 3 all the way up to 3. But is it equals to 3? No. So minus 3 is not included. And is it also equals to 3 here? No, it's not. So that one also, it's not included. So x is an element of minus 3 to 3, and it's not included. Okay, so the second way of solving this would be to actually draw the parabola, okay, where y is equals to x squared minus 9, okay? So y is equals to x squared minus 9, all right? And we want to know where is it that this here is less than 0? Which values of of x would make y be less than 0? So remember we said these two are our critical values. When it's here, y is equals to 0. So we want to know where is y negative. Y is negative from x is equals to minus 3 all the way up to x is equals to 3. You can see that it's below the x-axis, all right, which means that it's negative. So here as well, when you're drawing it graphically, you are able to see. If the question was where is y positive, you can see when the line is above the x-axis, y is positive. But here we want to know where is it negative, where it's below the x-axis. So it's when x lies between minus 3 and 3, like I showed you previously. Let's move on to another example. Okay, the next example here as well, all right? We bring everything over to this side. So this sign will tell us whether our function is going to be positive or negative. So we have x squared minus 5x minus 6, okay? It's less than or equals to 0. And then we factorize this, so it's x minus 6 times x plus 1, okay? It's greater than or equals to 0. So my critical values are going to be where x is equals to 6 or x is equals to minus 1, all right? So now I go and I draw my table. Okay, so let's draw the table. So here, firstly, I'm going to have, okay, x minus 6. Then I'm going to have x plus 1. And then I'm going to have the product of the two values. Okay, because that's the answer that I'm looking for. Then in ascending order, all right, I start off, I put my critical value, my first critical value, which is -1, okay? And then my second critical value is at 6, okay? So now with my signs, okay, remember now with the signs, here I'm saying x lies between -1 and 6. Then on this side, I'm saying x is less than -1, all right? And on this side here, I'm saying x is greater than 6. Okay, so now let's do the same way in which we're doing in the first example. So I'm saying when x is equals to, so we always start off with our critical values, right? And we write it on the line. So when x is equals to -1, what happens here? So when x is equals to -1, I get -1 minus 6, which is -7. So it tells me here that this value here is going to be a negative value. When x is equals to -1 here, -1 plus 1 is 0. So therefore, when I multiply these two where x is equals to 1, then a negative times a 0 is equals to 0. All right? Now, when x is equals to 6, I get 6 minus 6, which gives me 0. When x is equals to 6 here, I get 6 plus 1, which is a positive value. Okay? And 0 times a positive value gives me 0. Okay. Then we say, what happens in between the two when x lies between -1 and 6? So let's choose again 1. So if I have 1 minus 6, I get a negative value. When I have 1 plus 1, I get a positive value. So when I take these two values and I multiply them, I'm going to get a negative value. All right? Then we go here. Okay, then we say when x is less than 1. So now I'm choosing a value like -2. So -2 minus 6 gives me -8. It's a negative value. Okay, -2 plus 1 is -1. So that gives me a negative value. So when I multiply those two values together, I'm going to get a positive value. All right. Here as well, when x is greater than 6, okay? When x is greater than 6, let's choose 7. So 7 minus 6 is 1. That's a positive number. When 7 plus 1 is 8, that's also a positive number. A positive number multiplied by a positive number gives me a positive number. Okay? So now, my answer, what is going to be my answer? Here we are saying which values of x, okay, that if I put in here and I multiply these two, I'm either going to get 0 or I'm going to get a positive number. All right. So where do I get a positive number? I get a positive number here when x is less than -1. I get a positive number here when x is greater than -1. But also, where do I get it equals to 0? I need to include that. So I also get it here where it's equals to 0 when x is equals to -1. And I also get it here where it's 0 where x is equals to 6. So how do I then write that? Okay, so my final solution is going to be where x is less than 6, where x is less than -1, okay, where x is less than -1, but also where is it going to be equals to 0? So here as well, where it's equals to -1 as well. So when x is less than or equals to 1, and here as well, when x is greater than or equals to 6, because when it's equals to 6, my solution, my product becomes 0. Okay, so if we write that properly in set builder notation, it will look something like this. Okay, so x is less than or equals to -1. Okay, or x is greater than or equals to 6. Okay, and x is an element of the real numbers. Okay, and then if I was to draw a number line, so how would that look on a number line? Okay, I would have -1 here, I'd have my 6 there, so then it will be a closed circle because I'm including the 1. It is equals to 1 and it's less than. All right, here as well, it's including the 6 and it's greater than. So that's how it would look on my number line. And then with interval notation, all right, I would write it as x is an element of from -infinity all the way up to -1, okay, or x is an element of from, sorry, so including, because this is including -1, okay, or it's from 6, it's equals to 6 all the way up to positive infinity. Positive infinity is always an open bracket, even negative infinity is always an open bracket. So if we were to then solve this graphically, you would draw the function, all right, you draw the parabola, and then from there, you would then see where are my critical values. Remember, the critical values are at -1 and 6, okay? So where is my graph equals to 0 and positive? Okay, so where is my graph equals to 0 and positive? And it's when it's above the x-axis. So from -1 all the way up to where x is negative, up to infinity, negative infinity, and also from x is equals to 6, my y is positive, all the way where x approaches infinity. Okay, so last example. Okay, so here we have a negative x cubed. All right, so then we have -x cubed plus 5x squared minus 4x is less than 0. Okay, and then we want this one here to be a positive coefficient. So when I divide by -1 across the board, I get x cubed minus 5x squared plus 4x. All right, but because I'm dividing by a negative number, then I change my sign and this now becomes greater than 0. So now I need to solve for my critical values. So first thing I can see, I have x as a common factor. All right, so then I'm left with x squared minus 5x plus 4, okay, is greater than 0. Okay, so then I have x. If I then factorize this, it's x minus 4 times x minus 1 is greater than 0. So my critical values, okay, so where x is equals to 0 is when x is equals to 0, this first one here, or when x is equals to 4, or when x is equals to 1. Okay, we have proved it here. So those are my critical values. So now I do my sign timetable. My sign table. So I start off with this, it's the product. So I start off with x, then I have x minus 4, then I have x minus 1, and then at the bottom, okay, at the bottom, then I have my product x times x minus 4 times x minus 1. Okay, so there's my product. Then I draw my lines. Let me just quickly draw with the lines. Okay, then the ones here at the top. Okay, then I put my critical values in ascending order. So the first one is x is equals to 0. Okay, my second critical value is that x is equals to 1. Then my third critical value is when x is equals to 4. Okay. So now I have 3 critical values. Okay. So here we're going to have a scenario where x is less than 0. Then we're going to have a scenario where x lies between 0 and 1. Okay. Then we're going to have a scenario where x lies between 1 and 4. And then we're going to have a scenario where x is greater than 4. Okay. So now, let's look. When x is equals to 0, okay, when x is equals to 0, okay, this becomes 0. And it doesn't matter what the signs are going to be here. So I'm going to, okay, but maybe let's do it, okay? So when x is 0, I have 0 minus 4, which is a negative value. When x is 0 here, again, I have a negative value. So here I have 0 times the negative times the negative. It's still going to give me 0. So that's my critical value. The next one, when x is equals to 1, this one here is a positive sign. Okay. When x is equals to 1, this here becomes a negative sign. When x is equals to 1 here, this one is 0. Again, 0 times any value, you're still going to get 0. Then the last one, my critical value, x is equals to 4. That's a positive value. When x is equals to 4 here, you get 0. When x is equals to 4, I get 3, which is a positive value. Again, positive times 0 times positive gives me 0 as a value. Okay, so now what happens when x is less than 0? When x is less than 0 minus 1, for example, it's a negative value, isn't it? Okay, when x is minus 1 here, again, I get a negative value. When x is minus 1 here, again, I get a negative value. So I get negative times a negative is positive, times a negative is a negative value. Okay, so when x lies between 0 and 1, so maybe let's choose a half. Okay, so x is a half, that's a positive value. When x is a half here, you get a negative 3.5. When x is a half here, you get negative a half. So that's also a negative value. Okay. So then we have a positive times a negative times a negative. It gives me a positive value. All right. Now, when x lies between 1 and 4, so let's choose 2. X here becomes a positive value. 2 minus 4 is negative. 2 minus 1 is positive. So now what happens? You get a positive times a negative, which is a negative, times a positive, you get a negative value. Okay, so when x is greater than 5, for example, this one here is positive. 5 minus 4 is 1, so that's a positive value. 5 minus 1 is 4, which is a positive value. So here as well, when I multiply all three, I get a positive value. So now let's go back to our inequality. Okay, so you look at the end here. So now we're saying we're looking for values of x where when you multiply them, you get a number that is greater than 0. So where is my product positive? My product is positive when it lies here, and it's also positive when it lies there. Okay, are we looking for when it's equals to 0? No, there's no equals to sign here. So these critical values will not be included. So my answer is going to be when x lies between 0 and 1. Okay, and also where x is greater than 4. Okay, so that's my answer. So when you write it in set builder notation, okay, so x is an element of, it lies between 0 and 1, or x is greater than 4, and x is an element of the real numbers. If I was to draw this on my number line, okay, on my number line I'd have 0, I'd have 1, and then I'd have my 4. So then I would have it lies between 0 and 1. There's no equal sign, so it's an open circle. Or also then x is greater than 4. So x is greater than 4. Set builder notation. I have x is an element of, it lies between 0 and 1. Okay, so it's an open bracket. Or x is an element of, is the 4 included? No, it's not included, all the way up to positive infinity. And that's it on inequalities.